Hello, at this video I will be introducing the experiment of Kirchhoffs laws. Kirchhoffs laws are two equations used in the analysis of complex circuits based on the conservation of electric charge and energy, which defined by Gustav Robert Kirchhoff. Generally people call this name as Kirchhoff and the proper use is also Kirchhoff, but I choose to say as Kirchhoff. Anyway, the first law abbreviated as KCL, Kirchhoff's current law. Let me take in parentheses. In other name, it is called as junction law. Junction law. So, what does junction law states? It states that the total current entering a junction is equal to the total current leaving it. For example, if we have a current and junction like that, let us assume that this line I1, this line I2, and this line I3. So here we assume these lines are the branches of the circuit, and this is the junction, and I1, I2 enter in this junction, I3 leave in this junction. So the sum of the I1 and I2 must be equal to I3 as junction law states. Okay, so we can say that the current is conserved. The second law, abbreviated as Kirchhoff's voltage law, KVL, in other name is loop law. It states that at any closed circuit, at any closed loop, the voltages around that circuit or loop must add up to zero. I mean, in other words, let me explain in mathematical description, the sum of the potential differences across each circuit element must add up to zero. Okay, I mean the sum of it will be zero. Let's put this aside and look at here. If we have a resistor like that, and say this terminal is at 20 volts, this terminal is at 10 volts. So this terminal will be high electric potential and this terminal will be called as low electric potential. So as you know that current naturally flows from the direction of high potential to low potential. So current will flow in that direction. Let's say I. And so it flows from positive to negative. I can easily indicate that this terminal will be positive pole and this is negative. Then we know resistors consume the energy in a circuit, and anytime the current flows from the high electric potential to low electric potential, the energy of the charges that are flowing in that circuit is actually being reduced. I mean, energy is being transferred from the charges to the resistor. So the resistors decrease the energy of the charges. Now we're gonna assign a negative voltage to it because it reduced the energy per unit charge. Okay? And that's what a volt. And that's what a volt is, I mean. So voltage is basically the energy change per unit charge. I mean, it's actually per 1 coulomb. Okay, if we consider now a battery, okay, a battery, current can flow from the low potential to high potential. How? Let's draw the battery here. I mean, let's say it is 10 volts. So, as we know, this part is positive pole, this part is negative pole. So, I can indicate that this terminal is at 10 volts and this terminal must be at 0 volts. Okay, and let's say when you see this, whenever the current is flowing from low potential to high potential, that means the energy of the charges is increasing And so this is gonna create a positive voltage because battery is transferring energy to the charges. And so it increases the voltage of the charges, but a resistor decreases the voltage of the charges. Now, let me show that the current will flow from positive terminal to negative terminal. So the direction of the current will be like that, from low potential to high potential. Since it increases the voltage of the charges, we will indicate also the potential difference across this battery as positive V. Yes. Now, let me consolidate this information with a question. Let's say if we have a resistor and a current is flowing in this direction, okay? Will we assign a positive voltage or negative one? Yes. Keep this in mind, my friends. A resistor always creates a voltage drop. It always consumes energy from the charges. So we always assign a negative voltage to it. But be careful. If the current is flowing from the positive terminal to the negative terminal, okay? And I mean from high electric potential to low electric potential. So now what if we reverse the terminals? I mean current is still flowing in the same direction, but now from low potential to high potential, as like that. Yes, as you can find easily, since the energy of the charges is increasing by the increasing potential, resistor creates a voltage lift here. So we assign the potential difference across this resistor as positive voltage. Now, let's talk about batteries. If we have a battery like that, that's listed in this way, and there is a current flowing in this direction, so this battery, is it increasing the energy of the charges or decreasing? The answer, as you guess, it is increasing the energy of the charges. So the potential difference across this battery will be written as positive voltage. But if we reverse the polarity with same current direction, let me draw it. Now, the potential difference across it will be negative voltage. Let's give an example and solve it using the loop law. Let's say if we have a battery and 3 resistors like that. Okay, and let's say this battery has 12 volts, and this is R1, this is R2, and let's say this is R3. Okay, and the value of the resistances as 8 ohms, 10 ohms, and 12 ohms. Now, let's write an expression that highlights the Kirchhoffs voltage law and show that the sum of the voltages around this circuit must add to 0. Now, the current is gonna leave the positive terminal of the battery, like that. Direction of current as clockwise. Okay, and so it's gonna be flowing in this direction. So as it flows through R1, R2, and R3, the voltages across each resistors will decrease since they decrease energy of the charges, but battery will supply the energy to the circuit. So while we are writing the voltages or potential difference across each circuit element, we will assign as like that. Here, this will be minus V1, this will be minus V2, this will be minus V3. And the battery will be plus V, let's say B, battery of the B. And what can we say also? We assign the potential differences like that. So as the loop law states that the voltages must add up to zero, So let me write here. I'm starting with the battery plus VV. I'm coming, and for R1 I will write the potential difference as minus V1. For R2 minus V2, for R3 minus V3. And loop is completed when I come to the negative terminal of the battery. So this voltages, I mean this subtraction or this sum, must be equal to 0. So this is the equation corresponding to the loop's law. And if we write the numbers here, VV is 12 volts minus V1. V1, since we know the Ohm's law states that V equals I times R, we can easily write for V1 as I times 8. So it will be minus I times 8 ohms minus I times 10 ohms minus I times 12 ohms will be equal to 0. So now this is physical interpretation, and for this subtraction get rid of the units and write only the numbers. So we will have as 12 and equals 30 I. So here the current will be equal to 0.4 amps. Okay. So when you do this subtraction, you see that it verifies the law. Now let's look at the circuit diagram in this experiment. We have two batteries here, V1 and V2, and the value of this V1 is 3 volts, V2 5 volts. R1 10 ohms, R2 20 ohms, R3 30 ohms, and R4 is rated as 20 ohms. Yes, we will apply Kirchhoffs laws to solve this circuit. And let's remind the equations or the laws. The first law is the junction law, and the second law is loop law. We will first apply the junction law. As junction law states that the total current entering a junction will be equal to the total current leaving it. When we look at our circuit, we see that this is our junction. I can also choose this junction, but I will apply my expression, my calculations according to this junction. Okay. Now we will randomly choose the current directions. Since V1 is here, and since this is positive pole and this is negative pole, I will make the direction of the current in this way. Let's say this is I1. And for V2, let's define the second current as I2 in this way. So I1 flows like that, I2 flows like that. And let's say this I1 starts from the positive terminal of the V1 and come to the R1. Then it will flows through R2 and R3, then reaches to this junction, and then again to the end of the negative terminal, so it completes the cycle. So here, when I close this part, you see we have a loop here, a circuit here. Also, when I close this part, you will see we have another loop, another circuit here. So now, before defining the direction of the loops, I'm keeping to continue for defining the currents. So for I2, let's look at here. I2 flows through this branch and come to this junction. This is I1, okay? So if I draw this junction here, I1 is leaving, I2 is coming. Here we have also another branch. And randomly, again, be careful, randomly, I choose the direction because in this branch, current will be different. And let's say it will be I3. And the direction is in this way. So I3 also is coming to this junction, entering this junction. So the first equation will be like that. I2 plus I3 will be equal to I1. Why? Because total current entering a junction will be equal to total current leaving it. Okay, this is first equation, which is obtained by the junction law. Then let's apply the loop law. For applying the loop law, again, we will determine or we will define randomly a direction. And here I choose, let's say, this direction, like that. And this is my first loop, okay? And direction is, let's say, counterclockwise. And here also, in this loop, I will choose my direction as, let's say, like that. Okay? Again, counterclockwise. Second loop. So, I will write my expressions, I will write the equations with respect to the direction of these loops. Because since we know some voltages will be negative, some voltages will be positive with respect to the directions of the loop. Let's start to write these equations. Now, I will start from this junction, okay? Now, here, I1 is flowing and comes to the battery. Since I1 flows from the low potential to high potential, okay, the voltage will be positive. Why? Because this battery increases the energy of the charges. So I will write V1 plus V1. Then I'm coming to R1. Let's say the potential difference across R1 is V1. Okay? So, will we assign V1 as negative or positive? Since we know current is in that direction, okay? And since we know this is positive terminal, so this terminal will be positive, this terminal will be negative. And the current flows from high potential to low potential. So it reduces the energy of the charges. So the voltage, V1, will be negative. So here I will write minus V1. Here, in order not to confuse V1 and battery, I will write V1B, okay, for battery, and for resistor V1. Let's put like that. Then I'm going on. For R2, I will write again the same logic, V2 and V3. Since R2 and R3 also consumes energy in the same direction, we will write minus V2 and minus V3. So we will reach the junction. So the equation will be equal to 0. Okay? Now let's put the values. For V1B, it is 3 volt. Here, I do not write the units. 3 minus, in terms of V1, we can say that, this is I1, we can say that V1 equals I1 times 10 ohms. Okay? So, I can write 10 times I1. Here, 10 times I1. Minus, for V2, here, pay attention, in this branch, the current is I3. Okay? So, I3 flows through R2 and R3. So, V2 will be equal to I3 times R2. So, it will be equal to 20 times I3. 20 times I3. Again, minus, because here minus, for V3, we will write 30 times I3 and equals 0. And this is the second equation. Now, look at the second loop. Here, we start with, again, our junction, and we will go opposite to the I3 directions, because our loop direction is opposite to the direction of I3. Here, I'm now here. So, if I pass from low potential to high potential, because since this is positive and this is negative, so this will be positive, this will be negative, this will be positive, and this will be negative. Since my loop direction is in the direction of from negative to positive, for V3, we will write plus, because current is transferring from the low electric potential to high electric potential. Okay? So, it increases the energy of the charges. So, in terms of V3, here, V3, I will write a plus. Also, for V2, I will write plus, same logic. Then, when I come to here, I2, here, I2 is in this way. So, since this is negative pole, this is negative and positive, since the current is flowing from positive to negative, it consumes energy, so it will be negative voltage. So I will write minus V4. Then, when I come to second battery, V2 I mean, my current passing from low potential to high potential, okay, here plus. So it increases the energy of the charges, so the potential will be positive as 5 volts or as plus V2. Then I come to the junction again and completes the loop, so it will be equal to 0. Again, in terms of V3, we will write what? I3 times 30. So it will be 30 times I3 plus, for V2, I3 times 20. So it will be 20 times I3 minus, for V4, we will write what? I2 times R4. So it will be equal to 20 times I2 plus V2 is 5 volts, so 5 will be equal to 0. So this is the third equation we obtained by the Loop's law. So now we have 3 equations and 3 unknowns. By mathematical manipulation, you can easily find all the current values and voltage values. So according to this knowledge, you will do these calculations yourself at your home. Thank you very much for your watching.